this course more precisely, but it's the predictability between two or more attempts to measure the same thing. And I'll put here or more attempts to measure the same thing. So given a bathroom scale example where I get on and everybody gets on and off this scale, it gives us each a weight. Then we get back on the scale and we get a second measure. And we can compute the correlation coefficient between the two measures. How predictable is the person who's heaviest the first time the heaviest the second time? Or is the person who's heaviest the first time come out just average the second time? Or the person who's heaviest the first time come out the lightest the second time? That would be a poorer reliability. And validity is the correlation between the tests and what it's supposed to measure. And we noted the following relationship between the two. Remember this ballot, we can phrase it this way, is that reliability is necessary, but not sufficient for validity. So it has to be reliable in order to be valid. But another way, if it's reliable, it may or may not be valid, but if it's valid, we know it's reliable. Or, I put it this way, remember this ballad. If it's not reliable, it's not valid. So something has to be reliable in order, and we can phrase it even more precisely if you take a course in tests and measurements. We have a course in the upper division on tests and measurements. It used to be required for all psych majors, but I think we now allow some people not to take that course. It used to be required for everybody, course on tests and measures. When you take that, you understand that reliability places an upper bound. On validity. So to the extent that something is unreliable, and you can measure degrees of unreliability or of reliability, and we'll be talking about that later, there's a functional relationship that the larger the reliability is, the larger the validity might be. But the smaller the reliability is, the smaller the validity can possibly be. So if something's unreliable, it can't be valid. All right? How many got these today, basically? All right, a lot of little hands, not big hands, little hands. I'll explain to you later. You don't need to worry about raising your hand. All right. Any questions about the assignment, the announcements or assignments? Shermer. Oh, excuse me, Shermer. For a second there, I thought you were trying to tell me he was in the operating room. He was in the emergency room, the ER. Yeah, Michael Shermer. Okay, any other questions today? Let's see, reliability, validity. What's the assignment so far? All right, so what do we mean by validity? Does a test, if you had an early pregnancy test, what should it predict? Whether somebody's actually carrying a child. It could be perfectly reliable and tell people, yeah, you're pregnant. Every day you take the test, keep saying pregnant, 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 but no baby ever shows up. That would not be a very accurate test with respect to reliability. And we can ask, and last time we were concerned about projective tests. Pallet criticizes, and you read in the chapter on personality, the projective tests like the Rorschach test and the thematic apperception test. Projective tests are famous for being unreliable. And what are some examples of projective tests? The Rorschach test. Incidentally, how many of you looked up to see what Rorschach looks like? A couple of people. Who should play him?
Brad Pitt.
Brad Pitt. Other people have noticed this. Yeah. He looks just like Brad Pitt. Actually, maybe even better looking. I don't know. We haven't seen him live. But, all right. So look up, by all means, look up these things. How do you do it? You go to Google or some search engine and you type in, you know, Rorschach, and then click on the button for images, and you'll see a lot of pictures of him. And some people have already put him right next to, they got a photo of Brad Pitt right next to him to make the comparison. All right. Now, one of the questions we could ask, and that we were asking last time, is how reliable are these clinical diagnoses? Well, the clinicians don't agree with each other when they're asked to interview a patient and come up with a diagnostic category. And remember, we have, so these are unreliable, let me just, and if they're unreliable, we know they're not valid. And yet there are still people persisting in using them. It's very hard, very resistant to get rid of wrong information. There's a lot of people, after you leave this class, you're going to discover a lot of people still think Columbus was the first person to say the world is round. That's a wrong idea. There's a lot of people that still think that Freudian psychoanalysis is a good idea as a type of therapy for people with problems. There's a lot of wrong information and projective tests. Once they got started, it's very hard to get rid of them. But we're going to be talking about a movement in American psychology and, well, more than just American psychology that argued against it. We'll be getting to that maybe by the end of today or certainly by the next lecture. One of the things you can ask is, how accurate are clinical predictions? What do we mean by a clinical prediction? Clinical prediction is when a human being uses their expertise and their interviewing powers and their powers of deduction and inference to make a prediction of something. So a human has access to information and makes predictions. Of human or other behavior. I'll write human right now, but it doesn't have to be human. What are some examples where you might be interested in predicting somebody's behavior? Well, whenever there's one of these events where somebody goes and kills a bunch of other people, then people say, why did you take that person with mental problems on a shooting range? Or why did somebody's mother, who's a weird kid, buy him that automatic weapon? It's a large magazine, holds a lot of ammo. Couldn't people have predicted what he was going to do? And then there's something called statistical prediction. And statistical prediction is where instead of using a human, you use a computer or a calculator. So you use a calculator, makes a prediction based on less evidence typically than is available to the clinician. Let me give you some examples of cases that have been studied. The classic case is predicting who's going to be placed in a mental hospital based on administration of personality tests. Oftentimes, the clinician has the availability of projective tests and the MMPI, and the formula only has access to something like the MMPI. MMPI, you read about, is the Minnesota Multiphasic Personality Index, and it was designed to discriminate between people that were in mental hospitals and people that worked in the mental hospital or were not in the mental hospital. But here are some examples that have been studied. We might want to predict crimes. By people who are up for parole. What's the situation for parole? You have a person that's in prison, and if you've been reading the newspapers, now that they're available to you free and you can get to them over at the student union, you've been reading that a crisis in California is that our prisons are absolutely overflowing, that the federal government has issued court orders to cut down the number of people in the prisons because you're holding people, 10 or 12 people in a cell designed to hold 2 people. It costs a fortune to keep the people in prisons. And one solution to the problem, it's hard to build prisons suddenly, is to let people go. So who should you let go is one of the questions. And parole boards have to make decisions about letting people go. So you have a person who was originally charged with 20 rapes, for example. They're brought before the police. The police say we have 20 people that have filed complaints. 12 of them positively identified you from a lineup. We have physical evidence in 2 of the cases. We don't want to take this thing to court. It'll cost a lot of money. It'll take a lot of time. We have to, the cost of the judges, the cost of the attorneys. It's expensive. If you'll plead guilty to 1 count, we'll guarantee you get a sentence of 12 years or less. We'll make that recommendation. Person says, okay, I'll plead guilty to 1 count. They've been charged with 20. They have good cases, maybe they could convict him on all 20 cases he's been charged with, but they got good cases, they could probably get him convicted on 10. But the person will plead in order to not have to go to court, and so they'll negotiate. So he signs an agreement, a plea agreement. The judge looks at the case and says, all right, I'll give you 10 years. The person gets sentenced to 10 years. After 3 years, they've been a model prisoner. They come before a parole board, and they say to the parole board, while I was in prison, I found God. And now I'm convinced that what I did was wrong. I'm never going to commit another crime. Let me out. And the parole board has to decide. So the parole board is asking this kind of question. If I let this person go, are they going to do more crimes? Because if they do more crimes, they cause people a lot of, what were the costs of the crimes? A whole lot of people are going to have pain and suffering. They're going to go to the police. The police are going to have to investigate. They're going to have to go looking around. They may have to go find the person to arrest them. They have to bring them in. They have to charge them. They have to create another case. It has to go to a district attorney. We have to get lawyers involved. You have to make another plea agreement. A whole lot of things go on. It's very expensive in a lot of ways, including pain and suffering of potential victims. So a parole board could do this clinically by looking at the person and saying, did that person find God? And does finding God help prevent them from committing more crimes? And are they sincere when they look at us and say that they're gone straight and not going to commit more crimes? And statistical formula gets to know something like the age of the person, the number of charged crimes, the number of prior convictions. In other words, if the person has a record of having been in more times, been in jail before, been in jail another time. Which crimes has the person been convicted of, and so on. So the formula, but the parole board has all this information plus more. They get to actually see the person. So this is one of the things you might want to predict. You might want to predict success in medical school. So this is a fairly negative kind of thing to predict, namely if the person's going to commit crime. You want to predict who's going to go to medical school and become a doctor as opposed to go to medical school for a year and then flunk out and never become a doctor. Or law school, or grad school. And you can do this by having a psychiatrist interview the people that want to go to medical school, or a lawyer interview the people that want to go to law school, or somebody interview the people that want to go to graduate school, and they have information about their grade point averages, or the graduate record exams, or the medical school aptitude test, or the law school aptitude test, MCAT, and so on. So there's predicting success. Or you might want to predict job performance. Who wants to predict job performance? People who are planning to hire somebody. Do you want to hire somebody that's going to steal from the company? No, that would be a bad idea. So you want to predict, is the person going to show up on time? Or is the person going to keep, calling in saying, oh, I'm not feeling well today, or I have something else, I have to pick up a friend at the airport, so I won't be in, can you cover for me today? Or some people do a better job than others. Can you predict who's going to be able to do their job and be successful at the job before you hire them? What else might you want to predict? Well, I mentioned violence by people that are in a mental institution. So is this person who seems to be violent, is this person somebody who's safe to let go, or are they going to commit violence against somebody, like against their spouse or ex-girlfriend or whatever it is? Can you predict who's going to get divorced? So marriage counselors have been asked to predict. And the marriage counselors, they're the clinicians. In this case, they not only get to know the age of the people and whether they were married before and various other things like that, scores, but they also get to listen to them for at least a year in the study that I'm going to describe. They get to listen to the people giving their complaints and explaining what it is that the other person does that bothers them, what it is that they think they should do about it, and talk about whether they're seriously considering divorce or not when they come in for the counseling. Or you might want to predict how long somebody's going to live by doctors. So the clinician in this case would be a doctor who's asked to predict how long somebody is going to live based on their biopsy results and their other medical test results and so on, which the statistical formula, the doctor gets to examine and look at the person and see the whole picture, whereas the statistical formula has to put together simply what's in the chart, the kinds of things that can be typed into the computer that enter it. Now the first person to study this based on the MMPI was Paul Meehl, who is a big name, was former president of the American Psychological Association, is now passed away, but important contributor to the field of clinical psychology. I mentioned him last time as having this exam item where he would ask us clinicians, if you want to predict who's going to be schizophrenic, what piece of information would you use to make that prediction? And the right answer was they have an identical twin, and then if somebody has an identical twin that's schizophrenic, that's the best thing you can use to predict who's going to be schizophrenic. Well, there have been hundreds of these studies, and here's how they come out. Turns out that the statistical, in more than 100 studies, the statistical formula beats the clinician. So there have been more than 100 studies. These have been summarized starting with Paul Meehl, who wrote the book called Clinical versus Actuarial Prediction, the first a book of this type back in the 1950s, and since then there have been more than 100 studies. Some of them have been reviewed by Dawes, who wrote a summary article on it a number of years ago, and every so often somebody updates the literature by writing a review article. And these show that statistical formula are more accurate than the clinicians. Contrary to what many people believe. Now, why is it that people come to believe this? It turns out that oftentimes the clinicians appear on television explaining that they made prediction that so-and-so was arrested. I remember I said it was going to be a Lithuanian, and that he was going to wear a double-breasted suit, and that he was going to be like this. And sure enough, that's who it was that committed the crime when I was asked to do this personality profile and predict who was it going to be that was doing this crime. Well, it turns out when you check up on these cases where the people make the claim that they made the prediction, they didn't actually make the prediction. I don't know if this is in all the editions of Callett's book, but he gives an example like that, where the people have basically lied on television and bragged about the accuracy of their predictability. Also, there's the theory that the statistical formula has less information available to it, but the human has more. And so the human should be able to take advantage of the fact that they get more information. They can tell whether these people are lying when they said that they had found God and weren't going to commit more crimes. They could tell who it is that's trying to con them. So it turns out people are not very good at distinguishing, telling who's lying. On the other hand, people have a great deal of conceit. Robin Dawes used the word cognitive conceit. People have a tendency to think that they're really good at combining information. Now you can ask yourself this: when you go to the supermarket and you have a basket full of groceries, there's an expert there, the person, namely the person that rings these things up. They have a whole lot of experience ringing up this stuff every day. How do you think they could do if they were to look in there coming up with a good guess as to how much it costs? You might look in there and say, oh, I'd say about $183.10. Or do you want them to ring it up? Ding, ding. That's a perfect example of statistical versus clinical judgment. What is it that people are doing wrong? Well, one of these studies, I'll tell you, well, here's an example of divorce was done by Dawes, by Robin Dawes. Here's what the formula had. He asks two questions of the people. Question number one, on average, per week, how many fights do you have? Question number two, on average, per week, how many times do you make love? And if there's more fights than lovemaking, he predicts they'll get divorced, and if it's the other way around, he predicts they'll stay together. That's the equation that he used. Very simple equation. Very oversimplified. He doesn't pay any attention to anything they said. He just uses that as his formula. That formula is more accurate than the marriage counselors in predicting whether the people are going to get divorced or not. Hillel Einhorn, he got some bad news. The doctors told him he had 6 months to live. And he said, oh, well, it's kind of like you guys heard the story probably about the guy got the phone call from his doctor. The doctor says, I have some bad news and some worse news. He says, okay, what's the bad news? He says, the bad news is your test results came back and you have 24 hours to live. He says, what's the worst news? He says, oh, I forgot to call you yesterday. So the guy says to his wife, all right, honey, let's go up on the mountain and make love and watch the sun come up. She says, that's fine for you. You don't have to get up in the morning. So he goes to bed. He's laying there in bed and he smells his favorite cookies. He smells cooking downstairs. So he's waiting to die. He says, well, maybe I can drag myself downstairs. Drag himself downstairs. He reaches for the cookies. She slaps him on the hand and says, those aren't for you. Those are for the funeral. Anyhow, so Einhorn got the message he had 6 months to live, and he said, I wonder how accurate doctors' predictions are of how long people have to live. So he looked into it, he found that statistical formulas were better, and then he compared what doctors were doing with the statistical formula to try to figure out why. And one of the things he noticed is that doctors weren't paying attention to the age of the patient. Now, if you know nothing else, here's what an actuary could tell you. If you don't know anything else about people, who's going to live longer from here on out? The 19-year-old or the 90-year-old? Right? I don't mean what age will eventually reach, but how much longer are they going to live? And it turns out the doctors were so interested in looking at the biopsy results and the table that says the average life expectancy if you have this test result is 5 years if you have this type of cancer. So they're telling people, you know, you have 6 months to live, but Einhorn was young at the time. He lived 16 years, was able to finish this research. So the prediction of 6 months, he decided to give away all his money on the basis, on the theory that he wasn't going to need it because he was going to die in 6 months. He would have been making a big mistake. He lived 16 years, not 6 months. And it turns out that the doctors were not very good. Oh, I knew this guy who applied to medical school. His test scores were really great, but they interviewed people. So he went, this was at SC back in the days when they interviewed the people for medical school. He went in, the psychiatrist, who's the one they asked, they said psychiatrists interview people. So we used them to interview the applicants to medical school. The guy asked him, is that a new suit you're wearing? He says, yes. He says, did you think you could impress us by wearing a new suit? He says, well, I did take the process seriously and I wanted to make a good impression, sir. But those aren't new socks you're wearing, are they? No. So your heart really isn't in being a doctor because you didn't buy the new sock. Now you see, you can ask yourself this question. Has anybody done a study to find out, is there a good correlation between, can you predict from sock purchasing to success in medical school? Has somebody done that study that the doctor should pay attention to this? He didn't get in. That should you reject somebody from medical school based on the predictability of sock purchasing? Nobody's done that study. So one of the things that people do is they make up little stories for themselves that have no predictability whatsoever. And they have a lot of error. People forget things. People have an amazing limitations on what they can remember, and they're not paying attention to everything. So they're only attending to some things. They only remember some of the things. And they aren't able to really calculate and put numbers together. Like when you look at all that stuff that goes bing, bing, bing on the conveyor belt, are you able to add it all up in your mind quickly? Well, a computer can do that. That's what computers are good for doing. They're good at putting information together, not forgetting it. And the statistical formulas typically have been based on actual empirical relationships as opposed to, or some kind of sound theory like more sex and fewer fights. So anyway, that's the way that result comes out. That people trained to make the predictions do worse than a calculator. That's one of the reasons that psychologists all study statistics, because the statistical formulas do a better job than a trained person at doing it intuitively, psychologically. And we're going to start studying statistics. So the first thing for you to memorize is that x sub I and it's x sub I, the little I here, is a subscript. That means it's lowered from the line, although maybe it'll look like it's on the same line. It stands for the score for case I. y on variable x. And what might x be? Well, for example, we're just talking about a clinical versus statistical prediction case. It might be the number of crimes the person was charged with before they were recently. Remember, that's not the number they were convicted of, because they may go on a, they may have made a plea, a sentence plea, where they pled guilty to one crime so as not to be charged with 20. So you might look at the number of crimes they were charged with. So x might be the variable, and x sub I might be the number of crimes that, you know, case I is person I. So for case I, that's the individual. So you can think of I for the individual. Maybe yi might be some other measure, like the person's age or the number of crimes that they commit if they're released from prison or something like that. So yi would be the score for case I. So that's the same person in this case on variable y. And then I want you to memorize, so that's what x sub I stands for. And then here's some examples of some data. So let's figure out how to calculate the mean, the median, the mode, the midpoint, the range of these. So if I is 1, I is 2, I is 3, that's the first case, the second case, the third case, and in this case we have n. So n is the number of cases in this case. So we say there are n cases, and in our example, n is equal to 9 in this case. So we're going to draw a frequency distribution of these numbers. So here's how to draw a frequency distribution. Can I erase this? Any question here so far? So how do you memorize that x sub I stands for the score? Well, you can put them on 3x5 cards. You can write x sub I on one side, and on the other side you can write the score for case I on variable x on the other side of the card, so that you can remember what's the score for case I on variable x. We write x sub I for that. Or what is x sub I? Well, that's the score for case I on variable x. Any questions here, Race? Here's how to draw a frequency distribution. So we're going to plot frequency on the y-axis. This is called the y-axis, or the ordinate. And we're going to label it appropriate to the case. In this case, our frequencies don't go very high. That's the number of cases. And on this axis, we're going to put the values of x. Value of the score. Later I might write just f of x over here and x down here. Refer to that. If this is called the ordinate, and this axis is called the abscissa, or the x-axis, right there. And then we're going to count. How many cases are there who had value of 0? Well, we can go through here. We see that x2 was 0. x4 was 0, that's 2, x5 was 0, that's 3, and x sub 8 was 0. So there are 4 cases, and I'm going to make a little histogram here whose height is 4. You can think that each little box here, so I can build it up, represents one case, and I could darken that all in, and so we're making what's called a little frequency. This kind of graph is called a frequency diagram, or frequency distribution. This particular kind of graph is sometimes called a histogram, because I'm making little boxes. When they're little boxes, you call it a histogram. How many ones are there? Well, you can go through and you can see there was only one 1, so we'll make a box whose height is 1 over the 1. How many 2s? There weren't any 2s. So the height of the box here should be 0 to represent that there weren't any 2s. How many 3s? 1, 2, 3. There were 3 3s. So I'm going to make a box here whose height is 3. Use my artwork. A little bit of a Dr. Seuss kind of a histogram there. How many 4s? Aren't any 4s or 5s or 6s. So we have 0s there, but there's 1 8. Right, there should be 9 cases, because n is equal to 9 in this case. So we should be able to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we should be able to add it up. So that's drawing a frequency distribution. And this frequency distribution is not symmetric. If it's symmetric, that means you could have draw a dashed line and fold it over and it would match. So this is not a symmetric distribution. A distribution that looks like this, and if you could fold it on the dotted line and it would match, that would be symmetric. Or one that looks like this, well, you could draw a dashed line, that would be symmetric. Or one that looks like this, normal distribution, you could fold it over and it would be, these are all symmetric. Or here's a U-shaped distribution with a lot of low scores and a lot of high scores. That's also called a bimodal distribution, we'll see in a minute. That's another example of these are all symmetric distributions, but this one's not symmetric. And so asymmetric distributions means not symmetric. Person who's amoral is not moral, right? So we add the A on there to let you know it's not the case. All right, well, let's find the range of numbers. The range is equal to the maximum minus the minimum. So the range, you should memorize the formula. So the range of x is equal to x max minus x min, where x max and x min are the maximum value. The maximum value of all the numbers is 8. The minimum value of all the numbers is 0, so this is equal to 8 minus 0, and that's equal to 8. So the range is 8. The mode is that value of x that's most frequent. So the mode of x is that value of x that is most frequent. Well, there are 4 zeros. So what's the mode?
0.
The mode is 0, not 4. That's the frequency at the mode. So there were 4 cases that were 0, but the mode is 0. So the mode of x in this case is 0. It's the most frequent. It's the value, there are more of them than anything else. Yeah, that's not a very good looking 0 there. Yeah, I'm thinking Valentine's Day. I guess it looked kind of like a heart, didn't it? Valentine's Day is already past. Hope you followed my advice not to make any bad Valentine's cards. Got to be careful. All right. The median is the value of x that half the cases are higher and half the cases are lower. So the median, sometimes called the 50th percentile, has an equal number of cases above and below it. These are all words that are sometimes called averages. And you read in Huff's, or you will be reading in Huff's book, How to Lie with Statistics, about the well-chosen average. And we'll say a little bit about that in just a few minutes. So the median is that value of x. In this case, it's 1. Because there are 1, 2, 3, 4 numbers less than 1, and 1, 2, 3, 4 numbers greater than 1. And so the median, in this case, is equal to 1. Any questions about that? If you put the numbers in order, the median would be the 5th one, but some people forget to put them in order, and they go down here and they say, oh, this must be 0, because that's, let's see, 1, 2, 3, 4, 5. X sub 5 was 0. No, don't do it that way. Don't think of it as the middle one. It's only the middle one if you put them in order. So if you put them in order, you've got, 0, 0, 0, 0, 1, and then 3, 3, 3, and 8. So the median is 1. All right. Any question about the median? And the midpoint is that value of x that is halfway between the two extremes. So we take the minimum and add the maximum and divide by 2. So that's equal to, the minimum is 0, the maximum is 8. 0 plus 8 divided by 2, so that's equal to 4. So the midpoint is equal to 4. And the mean is the sum of the x's divided by n. Erase this right here. We use x bar to stand for the mean, and x bar is equal to the sum from I equals 1 to n of x sub I divided by n. Well, what is this symbol sigma here? This is a Greek sigma, and in mathematics it means the sum of. So sigma is like the letter S, and the sum begins with the letter S. So people use this to represent the sum of. So the sum of from I equals 1 to n means you add, you take x1, you start it with 1, and you go up till you get to n, and then you stop. And so the sum of from I equals 1 to n of x sub I is equal to x1 plus x2 plus x3 plus, and then we put in dot, dot, dot because we get bored, plus x sub n. So you start with 1, you add 1 until you get to n, and then you stop. This is sometimes called the upper limit. That's when you stop, and the lower limit is where you start. So you start, and you keep going up. I keeps incrementing by 1 each time. So this is the sum of x sub I from I equals 1 to n. So basically you just add up all the numbers. We take 8 plus 0 plus 3 plus 0 plus 0 plus 3 plus 3 plus 0 plus 1, and that's 18. So in our case, that's equal to 18 divided by 9, and 18 divided by 9 is equal to 2. And so the mean in this case is equal to 2. All right, any questions about the mean, the median, the mode, and the midpoint? So you'll need to know, I want you to memorize the definitions of them and the formula for the mean. So memorize the formula for the mean. Memorize the definition of the range and of x sub I. So that's your assignment for right now. Any questions about those so far? All right. That's the next course in the Psych sequence, and I'll be giving you some more information about it. Now let's say a few words about, these are symmetric distributions. asymmetric distributions, this one, the mean, median, mode, and midpoint are all the same in this kind of distribution. In this one, there isn't a unique mode, right? This one, there are two modes. This one's bimodal. This bimodal. So a bicycle has two wheels, right? Biplane has two wings. Bimodal has two modes. This one's unimodal, symmetric. This one, the mean, median, the mode, the midpoint are all the same. This one also has a unique mode. It's symmetric, so it's mean, median, mode, and midpoint. This one, there is no unique mode at all there. The median may not be unique. There's another one that's so the mean is always unique. That means there's only one. Some things aren't unique. We've learned to live with that. How many people in here are named John? Nobody. Fred. Well, you probably know more than one person named John in the world, right? Yeah? So it's not unique. You say, who's named John? There's more than one right answer, right? If you're famous enough, I guess you only have to go by one name. All right. Or maybe two, like Lady Gaga, I don't know. That's two words are good. She's in the news right now because of the Oscars, right? Mm-hmm. All right. She did a pretty good job, I thought. Yeah. Didn't see why they had to criticize her on Fox News for that. I don't know. They can honor for that. Mm-hmm. All right. So we got the mean, the median, the mode, and the midpoint. And they're different from each other in asymmetric distributions. So what about asymmetric distributions? What are they like? Well, you could have a lot of low scores and a few large scores. And this one's like that. There's a lot of small scores and one large score. This kind of skew, the tail points to the right, is called positively skewed. And if you have a lot of large scores and a few small scores, so this is called the tail of a distribution. And if the tail points to the left, it's called negatively skewed. According to range frequency theory, happiness is a negatively skewed distribution. Now, according to a certain psychologist that I worked with, Alan Barducci at UCLA, his theory was that happiness was a negatively skewed distribution. All right, so there we go about different types of skewed. And in a positively skewed distribution, the mean is greater than the median. So hardly anybody is above average. Most people are below average. And in a negatively skewed distribution, most people are above average. So the mean is less than the median in a negatively skewed distribution. So most people are above average in that kind of distribution. Well, let me tell you about the Barnum effect. Any questions about the statistics we've done so far? So we're going to keep working on the statistics for a while, and one of the motivations is that humans are not as good at making predictions as statistical formulas, so you better learn how to use the statistical formulas if you're going to be a psychologist. And we're going to learn how to make predictions using correlation. We're going to be learning about that. That'll be coming up. Any questions about symmetric, asymmetric distributions, how to draw a frequency distribution? That's what your homework assignment is. Homework assignment, I'm not assigning the whole part 1 yet, but just problems number, you're going to do just number 1, 2, and 3, which is homework set 1A. And there's a link to that from the statistics. Okay to go? Going once? All right. Well, let me tell you about the Barnum effect. You read about that in the chapter on personality in Callett's book. I'm going to go over it a bit with you. You also maybe experienced it. You took a personality test, and how accurate did you think the test was? Most people thought it was pretty accurate that you took. Well, what you can do for the Barnum effect, depending on which edition you have, the Barnum effect could be in chapter 13 on page 562 or on 503 or 582. You can look up Barnum in the index, but I just noticed the 10th edition Barnum for some reason didn't make it into the name index. I don't know why. Whoever did the index missed it, but it's on page 582, I think, of that 10th edition. No, 482 of the 10th edition. What you do is you give some sort of test. Doesn't matter what kind of test you give. It could be a personality test, but we could drop wax in water, we could read somebody's tea leaves, we could cut open a pigeon and look at its guts, or sacrifice a goat and look at its entrails, or we could ask some expert to make opinions. We could have somebody look at the lines in your hand. All kind of things we could do. And then we give feedback. And then we ask people to self-validate it. So we ask people to rate the accuracy of the test. So how accurate was the test? So this is sort of self-validation. And the people rate it as being pretty accurate. And then we tell them, but you all got the same description, suckers. Let me read to you what you can tell people. For example, you might tell people, you have a great need for other people to like and admire you. You have a great deal of unused capacity which you have not turned to your advantage. Disciplined and self-controlled outside, you tend to be worrisome and insecure inside. You prefer a certain amount of change and variety and become dissatisfied when hemmed in by restrictions and limitations. You pride yourself as an independent thinker and do not accept other statements without satisfactory proof. You have a tendency to be critical of yourself. At times you have serious doubts as to whether you've made the right decision or done the right thing. While you have some personality weaknesses, you're generally able to compensate. Does this sound like you guys? Yeah, a lot of people seem to think so, because that's the description you got, right? When you took the personality test, you took the little big 5. Now, the way I've got it set up, the way I used to do it was more dramatic. Now I do it online. You know, in the old days we used to use paper and pencil. People took a paper and pencil test, and we took it away and said it was being scored. Then we gave them back envelopes. Everybody came up and got an envelope. And then to keep people from showing each other's descriptions to each other while they were rating how accurate it was, we would say, no, don't show yours to anybody else, because then they'll feel like they have to show you theirs. And this is personal. People don't want to reveal themselves to others. So don't even show yours to anybody else, and don't ask to see theirs, because this is why some people would come up white-faced, take the envelope and leave the room before they heard the rest of the story. Then they would get that description. Then he would rate the accuracy. And then, for those that hadn't snuck out the door to go open their envelope by themselves, you know. For those people who are still there, we'd say, you all got the same description, suckers. So how come you said it was accurate? And then always somebody would raise their hand and say, I say yes, he said, but I was correct because everybody got my description. And then the class would laugh because they all felt the same way. You know, it's like, well, yeah. I was right because everybody got the description of me. Now, if we don't mean, by personality, we mean how everybody is really the same, that isn't what we mean by personality, is it? You can't predict anything. except about people in general. I mean, you're not predicting anything. So people say it's accurate, and then you say suckers. Why do you say suckers? Because P.T. Barnum said that there's a sucker
Every minute.
every minute. Now, who was P.T. Barnum? Well, you've heard the Barnum and Bailey circuses. I mean, you hardly have any circuses left, but I think there's still a Barnum and Bailey circus. Before there was a Barnum and Bailey circus, Barnum was a showman. He got himself a bearded lady and a two-headed snake and a little tiny guy, you know, that he would exhibit. Here's a little tiny guy, fully grown, little tiny guy. And people would pay to go into his museum and go through and look at all this strange and interesting things in the museum. But there was fire laws, so he couldn't. People would go in and they'd wander around looking at the bearded lady, and they'd look at the little tiny guy, and you know, the two-headed snake, and they kept wandering around inside the museum there. And he wanted to get more traffic through because there were people lining up with money, you know, and he wanted to get them to go through, walk through, and go out. So he set up a door, and a sign on it said, "To the Tigress." And you went through the door, and it would slam behind you, and there was a cage with a tigress. And then there was another door, and it said, "To the Egress." And you'd go through that door, and it would slam behind you, and you'd be locked out. Because egress means exit, right? So, to the Tigress, okay. To the Egress, and they were out on the street. He got people going through his museum quicker. So he was interested in making money. And named after this, it's called the Barnum effect, because people think their description is really accurate, even when it isn't. So there's a tendency to be gullible. And gullible with respect to somebody else who claims to understand you or to predict things for you. Now, this is part of what's generally known to psychics who make a living, and there are ethical magicians and unethical magicians. So I got to just explain to you the distinction between the ethical magicians and the unethical magicians. The ethical magician says, "I'm going to fool you for your entertainment. It seems like I can read your mind. It seems like I can make money appear in the air. It seems like the girl floats without anything to support her and then disappears, or changes from a woman into a tiger, or from a tiger back to a woman. Or it seems like I tore up something and then restored it. But I didn't actually do that. I just made it look like that." The unethical magician says, "Yeah, that's what I actually did. I actually read your mind. I actually bent the spoon with my mind. I actually, you know, am predicting, I'm talking to your dead relatives." So in the unethical magicians, you had spiritualists. And what did the spiritualists claim to do? They claimed to be able to talk to your dead relatives for you. And people wanted to know if they were cold, or if they were in pain, or if they were in hell and burning. And if they forgave them for not repaying the money they owed them during their lifetime that they didn't pay back. And things like that. So people want to talk. The ethical magician, an ethical magician. Now, one of the rules of magic is you don't reveal the secret. You know, if you've ever had a magic kit when you were a kid, it says, "Don't tell a secret." Because you do something and somebody says, "Yeah, how'd you do that?" "Oh, well, I did this." "Oh, is that all?" The people say, "That's stupid." You know, it doesn't look like magic anymore. It's not entertaining anymore once you know how it was done. But when they can do something, you know, they put something here and then it's gone, you know. "Whoa, that kind of looks magical. How'd you do it?" "Oh, well, see, I just did that." "Oh, is that all?" You know, but how do you do it? If the person likes being left with the mystery. So you're not supposed to reveal the secret except When there's an unethical magician, then you're allowed to tell the secret.